Right, let's get on with question 8. So Aleph has an unbiased cubical, a 6-face die, on which the real numbers 1, 2, 3, 4, 5, 6. So that's like a common die that you'd be used to. And Beth has an unbiased tetrahedral 4-face die, on which the numbers 2, 3, 5, and 7. And so what we have to do is fill in the Venn diagram with the numbers. So inside A, we're going to put Alephs. Inside B, we're going to put Beths. And notice they have some things in common. They have 2, 3, and 5 in common. So 2, 3, and 5 are going to fit in the intersection. That should leave 7 there. And then it's 1 should go here. 2, 3, 4, 5, and 6. So that's what we should be looking at there. Okay, and so that's actually the first part. Really, really easy. We don't want to have any repeats in there. We just put in what's in common to both in the middle. And then what's left in set A goes in the remaining part of set A, and what's left in set B. So we have to find how many are inside what B has in common here, what B has in common with A dashed, which means everything not an A. So what I like to do is just sketch out a little diagram. So this is going to be the diagram of everything in B. So that's what that looks like. So this is just B, and what we're going to do is do A dashed, and that will be everything that's not inside A. So it looks like this, everything. So A is the only thing that is not shaded. This is A dashed. And so what do these two things have in common? They have this section here that I'm shading on the main diagram in common. And how many numbers do we have in there? Because it says n of that, and there is one number. So don't write 7. There's only one number in there. Okay. So let's have a look and see at the next part of the question. So Aleph and Beth are going to roll their die only once. Shin says the probability that each die will show the same number is 1 out of 8. So let's have a look and see. We'll do a little tree diagram in the bottom. That's kind of why I've left a little bit of space here. So we can either, if we look and see, to roll, we can either roll the same number or not the same number. So we can roll a 2, 2, couldn't we? We could roll a 3, 3, and we could roll a 5, 5. So there are all the possible outcomes that we could get. And let's do a quick tree diagram and see. So we could roll a 2. So the probability of rolling a 2 on the 4-sided dice is 1 out of 4. And then we could roll a 2 again on the 6-sided dice, and that'd be 1 out of 6. Okay, and that'd be there. We could roll a 3 on that dice, that'd be 1 out of 4. And we could roll a 3 again, and that would be 1 out of 6. And we could roll a 5, and that would also be 1 out of 4, and that'd be 1 out of 6. So actually, when we look at this here, that'd be 1 times 4, 1 over 4 times 1 times 6, which equals 1 over 4 times 1 over 6, which is 1 over 4 times 1 over 6, which is 3 times 1 over 4 times 1 over 6, which equals 1/8. So he is correct, because there are only 3 possible outcomes, and out of a total possible 24 outcomes, I believe. Okay, so the correct answer is yes. Shin is correct, and he is correct because we've shown that if we to roll this, we would have to get this result here.